we are going to take the derivative of f of x equals negative 3 divided by x to the negative 4/9. Now, this function looks a little bit strange. It's in a slightly odd form. So first, I'm going to rewrite my function, and then I'm going to think about how to take this derivative. This x to the negative 4/9 is a little bit annoying in terms of where it's sitting. It'd be nicer if that were x to the power something in the numerator, if we didn't have anything in this denominator. So the way we're going to fix that is to use a little bit of algebra. X to the power n in the denominator is the same as x to the power minus n in the numerator. So this function we can rewrite as negative 3 times x to the power positive 4/9, right? Because negative 4/9, the opposite of negative 4/9 is positive 4/9. Now we can use two properties of differentiation. So I'll write those out. So if f of x equals k, which is some constant, times g of x, then we know the derivative, f prime of x, is k times the derivative of g. So that helps us. We can take the negative 3. That's going to help us with this negative 3. Second property of differentiation is the power rule. So if f of x equals x to the power n, where n is not 0, we have f prime of x equals n x to the power n minus 1. So that's going to help us take the derivative of x to the 4/9. So we put these things together, and we have f prime of x, the derivative of our original function, is negative 3. We can just pull that out. That's property 1. Times, we bring the exponent down in front, so that's 4/9 x, and I'll just write it out, to the 4/9 minus 1. Okay, so we multiply these two things together. We get a 3 canceling, and we end up with negative 4/3. Right, the 3 cancels out with the 9. We end up with the 3 in the denominator. X to the 4/9 minus 1 is x to the negative 5/9. So that we're done. If we didn't want the negative exponent, not sure why, but if we didn't, we could rewrite this as negative 4/3, 1 over x to the 5/9.